If your desk trades on Solana, you're working from data that's already 15 to 80 milliseconds old. Not because your provider is slow, because of where they sit in the queue. Every RPC node, every gRPC stream, every explorer waits for shreds to propagate, reassemble, and then re-execute before it can show you anything. This terminal isn't waiting. You shouldn't either. These are Solana transactions pulled straight out of raw shreds. The packets validators use to ship blocks to each other, reconstructed on this machine while the block is still being built. This is Triton Shred Streaming. Setup took 20 minutes. Here's all of it. This is built for desks where earlier data has a dollar value attached. Arbitrage, market making, liquidations, copy trading, anything where you're racing someone else to the same opportunity and the winner is decided in milliseconds. 6 commands, that's the entire install, and I'm showing you all of it. A C compiler because the packet recovery math compiles down to C. Rust, the project pins its own version and fetches it automatically. Then clone and build the client on a 4-core box. That build finished in 32 seconds. So we want to open the UDP port. And then what you'll probably see, mine is already open, but what we'll probably see is that it's not actually open on your end. You'll see 2 of these, which will be this one here and this one here. So what we want to do is we're opening up these with this command here. And then we just want to check one more time on the status. And we'll see our 20,000 is good to go, and it says allow. One constraint worth knowing before your engineer starts: the feed runs from 5 cities: New York, London, Amsterdam, Frankfurt, and Tokyo. 1 full feed per data center. Your server has to hit 1 of them. Beyond that, it's not very fussy. Any host, any provider, 4 cores and 16 gigs is plenty. Closer is faster, and any of the 5 works. Now tell Triton where to point. In the dashboard, go to Shred Streaming, click Add, add your IP, your port, and a good label, as well as the city where you want to be streaming to you. Click Add. That's it. No ticket, no sales call, no waiting on anybody. Save it, and the feed starts arriving. The whole thing, 1 server, 6 commands, and 1 form. About 20 minutes of your engineer's afternoon. 1 command, it binds the port and prints what arrives. Each header is a batch. The slot, which shred built it, how many transactions came out. Underneath, 1 line per transaction, version and signature. Last in slot means you have that entire block, typically while the rest of the network is still assembling it. Every 5 seconds, a stats line. Packets in the raw feed arriving. Recovered is data shreds rebuilt from the error correction ones. That's packet loss being repaired in front of you, automatically with no gap in your data. Dropped should sit at 0. And if it runs but prints nothing, no error, just silence, 3 things in this order. 1, the firewall on your server. This caught me on a brand new box. Ubuntu had its firewall running, allowing SSH and nothing else. So every shred was being dropped at the door with no error and no warning. 1 command fixed it. 2, the port. Whatever you registered in the dashboard has to match what the client is bound to. The form defaults to 8002 or just a suggestion or placeholder. The client defaults to 20,000. So pick one and use it in both places. 3, check the IP you registered is actually the IP that you're on. All 3 are in the guide below. Here's the part your engineer will ask about: integration service. The reference client is about 30 lines, 1 callback, and every transaction arrives in it fully reconstructed. Accounts, instructions, program IDs. That callback is where your strategy goes. When you move past the example, it's a plain Rust library. One dependency line into an existing project, no service to run alongside it, no protocol to implement, no SDK to learn. 3 things worth being straightforward about because you'll trade on this. It's pre-execution. You're seeing intent, not outcome. No logs, no balance changes, no confirmation. Some transactions will fail. Treat it like processed and confirm anything that settles. That's the trade you're making for the earliest signal that exists. It's not private order flow. These are the same leader-signed, unmodified shreds every validator on the network receives. Nobody's being front-run and nothing is being extracted. Everyone gets the same packets. The only edge is how directly they reach you. And it's open source. The client you just watched compile is public. Read it, fork it, run it forever. There's no validator in your critical path and nothing to migrate off later. That's raw shred streaming. You own the whole pipeline, end to end. Nothing between the leader's packets and your process. One last thing, and it's the honest version. Everything I just showed you runs on a server you own, which means you also are keeping it alive, patching it, watching the drop counter, doing it again in every city you want a feed in. If your desk has infrastructure people, that's Tuesday. If it doesn't, it's an afternoon with Triton's sample code and an AI assistant, which is genuinely how I got here. So if you want the data without the servers, Triton runs this exact pipeline for you. It's called dshred. It comes over gRPC, and it's the same pre-execution transactions out of the same shreds. They do the reconstruction on their side, you open a stream and consume it. No server, no build, no firewall, nothing to maintain. It filters server side too. Include an account, exclude one, require one, so you subscribe to the flow you actually care about instead of taking the whole fire hose. Both come with monthly and pay-as-you-go options, so you can run this continuously or switch it on for a single high-value window or switch it off again. Current numbers are on the site. Both run on the same network, Triton's own validators, partner validators, and Turbine, raced against each other and moved over 00's private fiber. Whichever way you want to take it, you're on the shortest path that exists. So, if you want the pipeline inside your own process, take what I showed you. If you want the signal and none of the plumbing, ask for dshred. Same data, same speed, pick the one that fits your team. Guide and code are linked below, and if you want either of these pointed at your desk, talk to the team. They're the engineers that built and run it, not a ticket queue. I'll see you in the next block.